In this video, we will begin to discuss compound probability. Compound probability is the likelihood of two or more events occurring. When we play games, there are often times where we have to roll dice and choose cards from a deck, or spin a spinner and choose cards from a deck, or sometimes flipping a coin and rolling a dice if we're playing different games. So there's oftentimes multiple probabilities occurring, and that is a compound event. How many total combinations are there if you were to flip 3 coins? One way you can figure this out is to draw a tree diagram. Your first coin that you could land on could be heads or tails. Your second coin could also land on heads or tails. However, if we landed on heads the first time, we can draw a tree diagram to show that the second time we landed on heads or on tails. So this would be heads, heads as coin 1 and coin 2. And then for our third coin, we can also land on heads or tails. So then we're going to extend the branch again off of each of our options, heads or tails. So this shows that our first flip landed on heads, heads, heads. So that's option number 1. Option 2 is heads, heads, tails. Heads, heads, tails. Option 3 would be heads, tails, heads. And 4 would be heads, tails, tails. Now we're going to repeat those same 4 options, but instead of starting with heads, we'll start with tails. So tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. This gives us a total of 8 possible outcomes for flipping 3 coins. Making a list, which I showed on the previous screen, is another way of calculating how many possible outcomes there are. This one can be a little bit tricky if you lose track of ones that you've already written down. So try to come up with a pattern or a strategy so that you don't repeat or miss any. The third option, and this works for any time you are finding the total possible outcomes, is to use what's called the fundamental counting principle. And that's that you can multiply the total possible outcomes for each event by one another. So for example, when we flip the first coin, there are 2 possible outcomes. When we flip the second coin, there are also 2 possible outcomes, and 2 possible outcomes on the third coin. 2 times 2 is 4, and 4 times 2 equals 8 possible outcomes. That saves a little bit of time from drawing your list or your tree diagram. Let's use that idea to try to find how many possible outcomes if you roll a die, flipped a coin, and pick a card from a standard deck of cards. Remember, there's 52 cards in a deck of cards. That's 6 times 2 times 52, which is 624 possible outcomes. The second question says you are playing Farkle, a game that requires you to roll 6 dice. How many total possible outcomes are there? That is 6 options on each die times 6 dice. So 6 times 6 times 6 times 6 times 6 times 6 is 46,656 total possible outcomes for those 6 dice. How many possible outcomes exist in this scenario? A pizza shop has 3 crusts to choose from: regular, thin, and deep dish, and 5 toppings: cheese, pepperoni, sausage, mushrooms, and olives. How many different 2-topping pizzas can you order, assuming that your 2 toppings are not the same? This would be 3 for the number of crusts you have to choose from, times 5, the number of toppings for topping number 1, and then times 4, which is how many toppings are left for your second topping, because we're not repeating the same topping twice. So that's 60 different possible pizza combinations. All right, how many possible combinations? If you want to create a new passcode for your phone, and it is 6 digits long, including numbers 0 through 9. This would be 1 million possible outcomes because there are 10 digits if you include 0. 0 to 9, there are 10 numbers to pick from, and there are 1, 2, 3, 4, 5, 6 digits in your passcode. I have a few too many extra here by accident. 10 times 10, 6 times is 1 million. All right, one final challenge question for you. A password must be at least 8 characters long. How many possible combinations of passwords are there if you use 1 capital letter, 3 lowercase letters, and 4 number digits between 0 and 9? For each lower and uppercase letter, there are 26 options to choose from. So 26 for the capital letter, times 26 times 26 times 26 for our 3 lowercase letters, and then 10 4 times for our 4 numbers. That gives us 4,569,760,000 possible passwords. For this last question, if you pick a card from a standard deck, how many possible combinations exist? This could have 2 different answers, either 52 times 52 times 52 or 52 times 51 times 50. What is the difference between these two, and why might there be a different answer? Some games require you to pick a card from the deck, but you do not replace that card with another card. That means there's 1 less card in the deck each time. So you can see that depending on the rules of the game, your possibilities will change depending on how many cards are in the deck at that time.